In 2016, McKinsey posited a future where urban transport would be a key market growth area, particularly in emerging markets, where traditional rail customer landscapes shift towards more cost-effective, return-oriented strategies. Enter 2020, and COVID-19 is sweeping through the world. People stop using public transport. They're now scared. This puts pressure on already strained transport operator budgets, who are now more than ever needing their assets to perform and perform in cost-effective ways, whilst maintaining critical subsystems which are becoming more costly and more complex than ever to maintain, yet still need to meet requisite safety and compliance standards. Trovon specialises in the remediation of these critical rolling stock subsystems by employing proprietary engineering technologies and processes that extend service intervals and component life. Delivering a holistic, cost-effective service for the future requires a business model that melds the physical engineering world, know-how and processes with predictive maintenance, artificial intelligence, cognitive neural networks, and based on a convergence of disparate data sources, be they structured or unstructured, visual or centralized. I want to thank you for having me here today. It's really exciting to be amongst people who really get artificial intelligence. And rail is an often forgotten industry about how we can actually integrate and apply artificial intelligence to gain benefits. It's also really great to be in Texas for the very first time, all the way from Australia. And Australia is a long way from everywhere. And so I think a great way it's a really great way to introduce you to a platform we're calling Civix, which is a joint project between Spark Ignition and Trovon, aimed at disrupting the rail industry paradigm as we see it today. Before I get started, I'd just like to play you a short video that explains who Trovon are. By integrating real-time data analysis technology with unstructured information, maintenance can be automated and predictive so that components can be maintained just in time. This reduces lifecycle costs, downtime, and extends the operational paradigm. Despite lifecycle optimization being a key driver for asset operators and owners, traditional original equipment manufacturers are reluctant to pursue prognostic strategies, as longer asset life and service intervals would reduce their aftermarket revenues. Let's think Philips and the light bulb. A concrete opportunity exists to embrace these data-driven technologies and strategies that optimize and automate maintenance and enhance component performance. Civix is an integrated software platform that embraces data-driven strategy to optimize and automate maintenance programs and enhance component performance. Platform assists maintenance teams to focus on delivering maintenance objectives. It refocuses engineering teams from the development of data science models using open source algorithms and the efforts they put into trying to interpret threshold alerts in the context of individual data points across multiple fleets to undertaking value-added activities of root cause analysis and fleet reliability improvements. Simply, the Civix platform provides simple actions and insights and instructions and next steps. It takes the guesswork out of what maintenance teams need to do in the field. It assists maintenance planners to optimize their inventory, to reduce their human capital, and to improve control, and to benefit from more precise resource and task allocation. Many solutions in the market today purport to deliver on these key drivers. However, current solutions are using open source algorithms. They're using manual data cleansing. They're using a trial and error pipe generation approach to provide meaningless, isolated threshold detection capability and alerts. They succeed only in providing post-failure detection, especially in the complex systems we see on rail vehicles. And then, of course, there's the dreaded and many false positives. The current rail industry condition monitoring solutions provide operators with disparate and disconnected error codes, failure alerts, false positives according to threshold limits, supplied by and or with the help of the original equipment manufacturers who don't like the technology in the first place. And then hopefully these models help them determine and or predict a way of correcting casual factors. So in other words, these IoT platforms, and we'll just call them IoT platforms, are using machine learning with significant human intervention to try and understand data produced by complex systems in context in order to predict component failure, which could be a function of design or the interaction of a combination of components and or casual environmental factors. It's not surprising then that none of the available solutions actually facilitate automated or predictive insights, much less assist to optimize maintenance activities, extend service intervals, or reduce maintenance costs. In order to produce results in a rail context, an AI application needs to be able to ingest structured and unstructured data from disparate sources, to understand the technical and systemic relevance of that data as it corresponds to multiple fleets, to continuously adjust and correct for multiple casual factors. However, software alone is not enough to deliver real outcomes. Therefore, by applying the combined USPs of Spark Ignition's extended technology range and Trovon's engineering and life extension processes, the Civix platform mitigates asset failure and network service disruptions. It produces real, quantifiable operational and maintenance cost savings. It increases maintenance resource efficiencies and delivers asset life extension whilst disrupting residual value paradigms significantly. Civix has been developed from the ground up to ingest structured and unstructured data. Structured and unstructured data and contextual data, geolocational data, temperature, environmental factors. This comes not only from a myriad of sensors, but also from imaging, audio, vibration sensors, environmental factors, operational maintenance manuals, task instructions, root cause analysis. operational and timetable data, and it pulls it all together to produce insights that a maintenance engineer can simply action, and then the system learns from the result of those actions. Civix applies the combined capabilities of Spark Cognition's algorithms and Trovon's engineering expertise. It contextualizes system-wide data. It predicts failures. It identifies root causes. It proposes solutions and delivers maintenance actions and optimizes all resources accordingly. It is this capture and analysis of holistic maintenance and environmental data with an OEM agnostic commercial agenda and approach that facilitates predictive asset life extension optimization. It is generally anticipated that artificial intelligence will reach human levels by 2029. We believe that the cognitive abilities delivered by the Civix platform, leveraging the joint capabilities of Spark Ignition and Trovon, provide a significant step forward to achieving that goal today. Thank you. Enjoy the rest of the afternoon.